Okay, next thing we want to talk about is matrices. See something, we've already seen something that looks like a matrix, but I haven't really explained what a matrix is. I've just kind of used that notation. So first thing we need to understand is rows and columns, okay? Now, a row might be, for example, 3 to -6. Now, if I was typing this, I'd put commas between these because remember that we use commas to separate members of a row when we're typing out a matrix. We can't write it as an array in the way I'll talk about. Okay, so this is a row. And I could even call it a row vector because it's got 3 numbers. Okay, well, and this is something I'm going to call a column vector. You don't have to worry too much about the use of the word vector here. Okay, I can multiply a row vector by a column vector very easily. The rule is simply I multiply the first number in the row by the first number in the column, second number in the row by the second number in the column, third number in the row by the third number in the column, and add up those results. Now there are many, many applications where it's important to be able to do that. For example, if the numbers in this column, well, I'm not going to do that example. Don't want to write it out. I'll come back to it in a minute and actually write it out then. Okay, so let's just do this multiplication. 3 times -1 is -3. 2 times 5 is 10. -6 times 3 is -18. And that equals then -11. -21 here plus 10 gives me -11. Okay, so very easy to multiply a row by a column. Now the only restriction on multiplying a row by a column is you have to have a number in the column to match every number in the row. Okay, and every number in the column has to be matched by a number in the row, which means that the row and the column have to have the same length. Length not being the length of a vector, Pythagorean theorem and all that, but the number of elements. Okay, so I've got 1, 2, 3 numbers here. I've got 3 numbers here. I can match them up and do this. If I had 3 numbers here and 4 numbers here, the 4th number wouldn't have anything to match up with. It wouldn't make any sense to do this operation. Okay, so that's rows and columns. Okay, now let's do this. Let's go ahead and do 3 to -6. And we'll use the -1, 5, 3. But I'm going to add a row. Okay, let's just call the row 1, -2, 3. Okay, now what am I going to do with this? Well, I can always multiply rows by columns. It's one operation that's locked in. So I multiply this first row by this column, but I could also multiply the second row by the column, right? If I multiply the first row by the column, well, you see that I get -11. If I multiply the second row by the column, what do I get? I get 1 times -1 is -1, -2 times 5 is -10, 3 times 3 is 9. So I got -2 plus 10, -1 minus 10 plus 9. I better write that down. And I could have written down the 3 numbers here, but they're the same as what I had up here. So I get negative 11, negative 2. Now, I just, without explaining it, I put the result of multiplying the first row by the column here, right across from the first row, and the second row times the column, well, right across from the second row. So, first row goes in the first row, because this column vector could be considered as having one very short row and another very short row. Okay, first row, second row. Result from the first row times the column in the first row, result of second row times the column in the second row. Okay, so that's multiplying matrices, okay? Now, there's even another thing I can do. Let's say I've got two columns over here, same matrix here, but two columns. Okay, well, my first row times my first column is going to go here. Second row times first column is going to go here. But I can also multiply each of these rows by the second column, and I'm going to have a result for the first row times the second column, a result for the second row times the second column. What do you think I'm going to do about that? Where do you think I'm going to write those numbers? Well, I'm going to write them in a second column over here. Okay, so let's see, and check my arithmetic. I'm not guaranteeing I'm even going to do it right here, but that's going to give me 6, negative 2, negative 24. 6, negative 2, and negative 24. I think negative 2, negative 24 is negative 26. I think that gives me negative 20, doesn't it? Check again, 6, negative 2, negative 24. Yep. Okay. Again, check me. I could be wrong. Okay. Yeah. Short-term memory declines with age. Okay. 2 and 2 and 12 is 4 and 12, which is 16. So, when I multiply the first row by the second column, where does the result go? It goes in the first row and the second column, right there. If I multiply the second row by the second column, where does that go? Well, it goes in the second row, right across from the first row, and it goes in the second column because it came from the second column. Okay? Well, that's matrix multiplication. As long as my rows and columns, the rows of my first matrix and columns of my second matrix, have the same number of elements, I can multiply any two matrices, okay?